All right, homework 5.8, where we're discussing the table of integrals in the back of your book. There's 7 questions. You really don't need the tables for any of these 7, but I think I've made that point already, complaining in the videos. Here's the first one. This question, you might recognize this question. It looks very similar to something that we did back in integration by parts, where you have to use integration by parts twice, and then you get something that kind of looks like the original question, and you solve algebraically for that. Remember that? It was kind of a clever example. I couldn't figure it out when I was a tutor. At any rate, they're just asking you to do that question. You're like, all right, I guess I could do that question the way we did it. Kind of clever, sort of fun. Yes, or you can go to your table of integrals, and you'd think this would be under trig forms, right? It kind of seems like this is a trig form since we have sine inside here. But you actually go down to this inverse trig forms, and then underneath it, I don't know if this is like inverse trig forms continued or what's going on here, but I think you'll find one of these, maybe it's 98, that has e raised up to some power times sine of some power, and you could figure out what a is and what b is and do a u substitution, and then you can use this formula instead of our kind of clever way using integration by parts twice to solve this guy. Question 2. Another one that there's a table in your book that will help you. I think what they have in mind is your u substitution could be x squared plus 3. And so you can try doing that u substitution and see what's left. And I think you'll have something that fits. Do I just tell you which one? How about this? On this same page, very close to the one we just found, I think you'll find a different one here that will fit that problem after you do that substitution. It's worth pointing out that you could do a better u substitution if you let u be the natural log of x squared plus 3. Then the du gets rid of even more stuff, and this problem simplifies even further, and you don't even need the tables at all. But I guess the purpose is to use the tables, and if you want to use the tables, use just x squared plus 3. Question 3, this is pretty similar to the example that I did in front of you, except they make it even easier. Instead of x squared plus 2 down in the denominator, they give you x squared plus 5 squared. So you don't even have to think as hard as what a must be. The a is just the 5. They don't even write 25, they write 5 squared. Don't let the 6 throw you off. You can throw that out in front of the integral. And then this is, I think it's number 17. It's the one I demonstrated in the video. Question 4 here. The trick on this one, and I think they're trying to give you a hint when they put this 2x dx up here, is that if you let u be equal to x squared, then that will make du 2x dx, and this will simplify a lot. What you'll be left with is the square root of u squared plus 16. And if you go back to our tables, this first thing says forms involving the square root of a squared plus u squared. So maybe you can stare in this section until you find one that'll fit the form that you'll have after you do the u substitution. This one's kind of the same idea. You have to do a u substitution. They don't really try to hide the u substitutions that you do. I think on this one, do I just tell you all the u substitutions? I don't know. See if you can guess what the u substitution would be so that the du will be perfectly inside here. And then I think what you'll be left after you do that u substitution will be a trig form, because you'll have this sine squared hanging around, and maybe you can find something that fits in this trig form section. Moving right along, question 6 here. There's another u substitution to do here. 6 isn't all that dissimilar from 5. I think if you get 5, you can get 6. Really, the thing that will change after you do your u substitution is instead of having sine squared, you'll have tangent cubed. But it's another trig form. Maybe you can find that in this little section here. And then finally, question 7, this is doable. You know how I know this is doable without tables? Because you did this without tables. You did this when you did trig powers. Remember, it was miserable. You absolutely hated it. It was extra credit, so maybe you didn't do it. You could factor the 3 out in front, and then you have cosine to the 4th times sine squared. If you stare in here, I think you'll find one of them that deals with cosine raised up to some power sine. I'm just going to tell you this time. It's number 86 here. And you'll have to figure out what n and m should be. And a challenge with 86 is they give you 2 different answers. So essentially, you can either reduce the exponent on sine by 2, or you could reduce the exponent on cosine by 2. So when you look at this, it might make your life easier if you reduce the exponent on sine by 2, because then you'll just have cosine to the 4th. And if you just have cosine to the 4th, maybe you could find a different one in your table that'll reduce the exponent on cosine by 2. And if you can reduce it all the way down to 2, then maybe you can find yet another one in your table that deals with cosine squareds. And all of those you can do without using these tables. And I don't even know if the tables are that much easier when you use 3 separate tables. But that's the idea with this problem, and the person who wrote this problem had that in mind as far as using the tables.